Welcome back, everybody. And so, in the last two videos, if we just have a very quick recap about, if we can just zoom in here to this little scratch pad, see what pen we got, a red one. Let's get a white one. If we can just have a quick recap about what's been going on in the last sort of few videos, then we start off with some sort of source of data. And we have, imagine our source of data is some PDF document. What we've been doing is we've been splitting this up into various text chunks. And with those text chunks now, just in the last video, we just look at, okay, so each one of those text chunks has got some content, but also it's got some metadata. And so what we have been doing with that is, with those text chunks, now we have been passing that then into some sort of vector store. And this vector store holds all of this information, but as well as that information, we've got some embedding model, and so this embedding model is used in conjunction with this database to encode into a numeric representation all of these text chunks. And so then we've got the situation where some user comes along with some sort of query, and the embedding model is going to do a numeric representation of that query and then do a search in this particular database, find the most relevant results, and those relevant results are going to come back, and let's just say we've got a couple of those relevant results, and that query and those relevant results are going to be passed to the large language model, who is going to come up with some sort of response. So that's the basic RAG setup. And so we've been through all of this. So now you can imagine, and this is the case, that you want to improve your system. Now there are various places where you might want to improve this system, right down to whether you cut up these documents into larger chunks or into smaller chunks. But what we're going to be looking at in this particular notebook is this embedding model and the algorithm that we use to find the relevant text chunks. So let's get into that, get back to the notebook, let's zoom in, and you see here we've been using these embedding models where we get these dense vectors, these numeric representations with a lot of information. We're also going to look at Elasticsearch, which is going to be more of a bag of words method of finding similar documents. A bag of words, a sort of keyword sort of search, if you like. And so it's not always obvious which algorithm is going to be the best to get you results. So we're going to have a little look at that in this notebook. And so, as you see, we're working with Llama Index in this case, and we're reading in some sort of PDF. So we've got a PDF reader, and we're hooking ourselves up to OpenAI, and we're going to give the password. And so all that's already been run, so we won't bother with that. And let's get down to this. So the first thing we want to do is get our data. And so we've got this directory reader, and this time I'm here loading two different documents. And I've got train data here and I've got validation data, because initially this notebook was set up to do some fine-tuning of this embedding model, which we'll do later on in this series, but we're not going to look at today. And if you're doing that, if you've created a fine-tuned model with some training data, you're going to need some different data in order to test it. So I've got these two sources of data, but we're only going to use one of them. We're only going to use this train data in this notebook. Let's just check out the time. How long have we been running for here? Okay, we've been running for 5 minutes. We can continue. So this train data is an Excel file. It's basically a how-to guide or what's new guide with Excel 2010. It's some PDF, and I don't know how many pages, maybe about 60 pages long. So once we've got that data, we can load it. We get our simple node parser. We've seen this before. I want a chunk size with a certain chunk overlap, and then we have our documents split up into these text nodes, these chunks. And you see in this train data, we've got 83 of them. Now, of course, we go through the same thing again and again. We're in Llama Index. That means we get this setting instance, and we can attach our embedding model. In this particular case, it's going to default to the OpenAI embedding model, but we can override that, and we can go out to Hugging Face as we have done here. Put in your Hugging Face token, and then we can get this Llama Index wrapper of Hugging Face, and we can choose our own open source model as we do here in this cell. And simply now we're going to attach that model to this instance of settings, and there we should have, when eventually the notebook catches up and we've installed this appropriate library, it's going to catch up with us, and we will now have this embedding model. So what we're going to do now, and I think we can just switch over to a quick explanation. I'll just check the time again. We're at 7 minutes. We're okay. Let's switch back over here, and we're going to see a particular problem that we're going to run into, because now we're going to be dealing with different embedding models. We're going to ask the question, well, which one of these models is best, and we're going to need to test that in some way. So we can imagine a scenario now is we've got some sort of query, and with this query, we've gone out to some sort of embedding model, and we've said, well, give me a list of results, and so it comes out with a list of results, and we get 1, 2, 3, and it says, okay, well, this is the best result, and this is the second best result, and this is the third best result. And so maybe we do the same thing, but this time we ask some other model, and embed 2 and embed 1. And so this embedding model gives us a list of results as well. And the list of results here, it gets its first and its second and its third. And so maybe these first results are the same, the second results are the same, and the third one is different. But when we look at them, we see, oh, well, they're still kind of relevant. Which one is best? And it's very difficult to actually pull this apart, especially when you're dealing with a huge amount of examples, and you look at them, and it's very difficult to say, well, I think this model is better. Let's kind of get into this list of these text chunks. What we're going to actually do is get a large language model for each text chunk to generate a couple of questions. A couple of questions that could be answered by the information in this text chunk. And then what we're going to do is we're going to ask an embedding model, okay, here's a question, find me amongst these documents, which one is the most relevant? And of course the answer should be, okay, this is document number 1. Now, what we're going to use is a metric called the mean reciprocal rank. And if this embedding model has managed to get the right answer, we're going to give it a score of 1 over 1. And we're going to use this rank. If, for example, when we ask the embedding model, okay, which is the most relevant text chunk, and maybe it says, okay, it's the second one, and this one it puts second in the list, then the rank of the ground truth is going to be 2, and the reciprocal rank is 1 over 2. It's going to get a score of 1/2. So this score of 1/2, then what we're going to do with all these text chunks is take the average of this text chunk, and once we take the average, we're going to be left with a number between 0 and 1, and by doing this, we're going to have some sort of metric, some sort of score by which we can judge these embedding models. So there you go. We'll look into the technical aspects of how we're going to do that in the next video, because we're just running a little bit long. So in the next video, we'll go through exactly how we're going to do that with Llama Index. So I'll see you guys in the next one.